Today we're going to be talking about foiling. FOIL is a way to multiply two binomial expressions together. When we talk about a binomial, we mean an expression like x plus 4, where you have two terms, x and positive 4, that are separated by a plus sign or a minus sign. So in this case, our two binomials are x plus 4 and x plus 5. So FOIL is really an acronym. An acronym just means the first letter of each word makes another word. So the F in this acronym stands for first. The O stands for outside. The I stands for inside. And the L stands for last. And that's going to tell me the way that I'm supposed to multiply each of these terms together. Basically, I need to multiply the x by each of the terms in the other set of parentheses. And I also need to do the same thing with that positive 4. So we'll start off by doing the first in each of these sets of parentheses. So x times x is going to give me x squared. Now we'll go to the outside. That means the first one in the first set of parentheses and the last one in the last set of parentheses. So this x times this positive 5. So x times positive 5 is positive 5x. Next up is the inside. So we have positive 4 times positive x gives me a positive 4x. And then the last, we have positive 4 times positive 5 gives me a positive 20. So if you draw the lines the way I drew my lines, you can make a little smiley face out of it. You don't have to do it that way. But it's super cute. Once we get it down to this expression, I'm looking at it and I'm noticing that I have two x terms here. My x squared doesn't have any common or like terms in my expression, but this positive 5x and positive 4x are both like terms. So I'm going to want to combine those to make this as simple as possible. So that x squared is just going to come down. Positive 5x plus 4x is going to give me positive 9x. And then that positive 20 just comes straight down. So these two things are going to be equivalent. If I were to write this in a table in y1 and this in a table in y2 and use my graphing calculator to see what values I would get, those tables are going to match exactly, okay, because they are equivalent. We've done the work to make those two expressions equivalent to one another. All right, so let's try another one. This one's going to be the same kind of idea. We're still working on that FOIL, F-O-I-L, first, outside, inside, last. But now it's just a little different because we have this minus sign. We just have to be a little bit more careful. The steps are exactly the same. We just need to kind of work through it with that negative. So we'll start out with our first. We have x times x gives me x squared. Our outside is positive x times negative 2, which is going to give me a negative 2x. The inside, positive 3 times x, gives me positive 3x. And then the last, I have a positive 3 times a negative 2, gives me a negative 6. So again, I'm noticing that I have the same term here in the middle. I have an x here and I have an x here. So when I combine my like terms, I'm going to be left with x squared. Negative 2 plus 3 is positive 1x. So you don't need the 1. If you want to put it, you can put it, but you don't need it. It's understood to be there. And then that minus 6 just comes along for the ride. All right, so not too bad. We can also do this if we don't have a coefficient of 1 for our x term. So let's take a look at a problem like that. What if we had something that looked like this? 2x plus 3 and then 4x minus 5. So those numbers are getting a little bit bigger, but it's the same process every single time. So let's try this one together. First, we would do 2 times 4 is 8. X times x is x squared. Outside, 2x times negative 5. So we multiply the 2 and the negative 5 to get negative 10. And the x just comes along. We do our inside. Positive 3 times positive 4 is positive 12. And then that x comes along. And our last. Positive 3 times negative 5 is a negative 15. So we're right back to what we were doing before. Looking for our like terms to combine. I have an x term and an x term in the middle. And we are going to be left with 8x squared. Negative 10 plus 12 is positive 2x. And our negative 15 just comes along. All right, so we might come across something that looks like this. So it doesn't look like I have two binomials here to use FOIL, but this squared tells me I'm multiplying this thing by itself, no matter what it is, whether it's a single number or a single variable or something in parentheses. Whenever you see that 2, you're raising it to that second power. You're multiplying it by itself. So for this one, you can rewrite this, and that should always be your first step. X plus 5 times itself, parentheses x plus 5. Again, we do the same steps. X times x is x squared. Outside, positive 5x. Inside, positive 5x. And last is plus 25. So when I put this together, we're going to get x squared plus 10x plus 25. But I'm looking at this, and this seems like there might be a simpler way to get this answer without having to do all this first, outside, inside, last. How might I think about this? I'm going to go ahead and put this together with all variables to see if we can figure out a simpler way. Let's say I have x plus a squared. All right, so let's do this in pink so we can know that this is going to be our generic process. So x plus a times x plus a. So we're going through the same steps. We have x squared plus, so that's our first, our outside. X times positive a is positive ax. Inside, positive ax. Last, plus a squared. So if I were to combine this, I would get x squared plus 2ax. You see I have 1ax here and 1ax here. That means I have 2ax when I combine those like terms. We're adding those coefficients. Plus a squared. So whenever you see a problem where you have an x plus or minus some number and that quantity squared, you can use this formula. To find this value here, you just do 2 times that value of a. To find this value here, you would just square that value of a. So for example, if we had x plus 3 squared, I know that the first term is going to be x squared. I know it's a positive. And then it says 2 times a. Well, if 3 is in the a spot, 2 times 3 is going to give me 6. Bring down my x. And then the last thing says a squared. So again, 3 is my a. A squared is going to give me 9. So that's just a little shortcut. This whole side is just a shortcut. If you feel better about doing it with the loops and doing the FOIL, that's totally fine. If you like a shortcut, that's your shortcut. So let's look at one more type of a problem. In this binomial, we have x plus 4 and then x minus 4. So it's the same number, but just opposite sign. So let's see what happens when we work this one out. So I have my x times x is x squared, outside, minus 4x, inside, plus 4x, and then last is minus 16. So when I combine my like terms here, I have a negative 4x and a positive 4x. That x term is going to cancel out. So I'm going to be left with x squared minus 16. What we can think about is that same idea of trying to make a shortcut when we see this type of a problem. So let's make it x plus a, x minus a. So if I'm gonna multiply first, x squared, outside minus ax, inside plus ax, and last minus a squared. When you combine all of the like terms, those are going to cancel, and we're going to get x squared minus a squared. So we know now when we see this type of a problem, we can use the shortcut. So let's say I'm going to do x plus 5 and x minus 5. I know I can use this rule, so I would have my x squared minus 5 times 5 is 25. Again, if you like to use the FOIL method, you can absolutely still do that. If you want to save yourself a couple steps, you can use this shortcut as well.